So I'm going to show you how to graph a rational function. So to start off, our equation is f of x equals 3x squared minus 5x minus 2 all over x squared minus 1. So to start off, we need to factor the numerator and the denominator, which you would get f of x equals x minus 2 3x plus 1 all over x plus 1, x minus 1. After factoring this, you need to find the x and y intercepts now. So to find your x-intercept, you need to set your numerator equal to 0, and to find your y-intercepts, you plug zeros into your x's. So to start off, we are going to find your x-intercept. Once again, to find your x-intercept, you set the numerator equal to 0, so you would have 0 equals x minus 2, 3x plus 1. So you would do x minus 2 equals 0, and you would do 3x plus 1 equals 0, which gives you, this over here would give you x equals 2, and this over here would give you x equals negative 1/3. So those are now going to be your x-intercepts. Next, we need to find the y-intercept. So to find the y-intercept, once again, you plug zeros into all of your x's. So your new equation would be 3 0 squared minus 5 times 0 minus 2 all over 0 squared minus 1, which would give you 0 squared is 0 times 3 is 0, minus 5 times 0 is 0, so that would give you just a negative 2 on top, and 0 squared minus 1 would be a negative 1. So your y-intercept would end up being 2. Next, we need to find out if we have any holes, the vertical and horizontal asymptotes. So to find any holes, you would look to see if any of these factors right here equal the same as any of these factors down here, or if they're the same, which they're not. These are all different factors, so that means that you have no holes. So next we need to find the vertical asymptotes. So to find a vertical asymptote, you need to set your bottom factors equal to 0. So you would have x plus 1 equals 0 and x minus 1 equals 0, giving you vertical asymptotes that occur at x equals negative 1 and positive 1. Next, we need to find out where the horizontal asymptotes occur at. Now, to find horizontal asymptotes, you need to look back at your original equation. As you look back at your original equation, which is located right here, you see that the powers right here are the same, and because those two are the same, then you have to look at your leading coefficients. And you divide your numerator coefficient divided by your denominator coefficient, which this is an understood line. So you would do 3 divided by 1, which is 3. So then you know that your horizontal asymptote occurs at y equals 3. So when you compile this information, you have x-intercepts occurring at x equals 2 and x equals negative 1/3. You have y-intercepts occurring at y equals 2. You have holes at none because you have no holes. You have vertical asymptote occurring at x equals negative 1 and positive 1, and then you have a horizontal asymptote occurring at y equals 3. So next we need to graph all of this information. So next we need to plot all of our information on the graph. So to start off, we need to plot our x-intercepts, which occur at 2 and at negative 1/3. Next are y-intercepts, which occur at 2. Our vertical asymptotes occur at -1 and 1. And our horizontal asymptote occurs at, occurs at 3. So, +3, which would be right here. To graph our actual lines, we know that the graph has to pass by this point, and this point. You also know that you have to have a graph going through here, and going up the middle. So if you know that the graph has to pass through this point, and go up, it can't possibly do this because it has to pass through this point. So then you know that your graph has to do this in the middle. Next, you need to you need to put your graph here, and you need to have a graph here. Now you know that it needs to pass through this intercept, so you know that it cannot do this. And you know that it cannot go straight up because it has to hug this line at one point in time and this line. So that tells you that your graph needs to go like this. Lastly, you need to have a line going through it here. Now you know that it has to hug both lines, so it needs to go somewhat like this. So you would put your line like this. Now lastly, you need to go onto a graphing calculator and graph some points and find out accurate points of your graph. Now as we look back onto our original graph with just our plots pointed and our asymptotes pointed, after we put it in our calculator, we see that it crosses at 0, 2, which is our y-intercept. At 0.5, it crosses at 5. So 1, 2, 3, 4, 5, it would cross about right there. And at -0.5, it's at about -1.7, so about right there. At 4, it crosses at 1.7, so at 1, 2, 3, 4, crosses about right here. And at 6, it is at about 2.1, so about right there. Next, you know that at -4, 1, 2, 3, 4, it crosses up to 4.4, so 4, about right there. And then at -6, 1, 2, 3, 4, 5, 6, it's at about 3.4. So after plotting these points, you can see that on our graph it will pass through at, like we estimated, right through here. Also, it will go through right there. And lastly, it will curve up right here. Now that is how you graph a rational equation.